All right, so now we're going to look at the four basic principles of object-oriented programming, and I'm going to give you kind of the simplest explanation of these four principles, and you're going to see these through the next dozen or so videos. You'll see how they play into object-oriented programming. So the first one is abstraction, and abstraction is where we hide all but the relevant parts of an object in order to reduce complexity and increase efficiency. So the easiest way to explain and understand abstraction is to look at something like your car. As a user of that car, do you really need to know the details of what happens when you start it? No, it's not your job. You don't need to know exactly how it works. You just need to know how to use it, things like the ignition, the gas, the brakes, etc. You don't need to know how the fuel pump works to drive a car. That's abstraction. It's the process of hiding the details of how something works and only showing the important parts. Now, since objects can get pretty large and complex, it's not usually possible to show the user of that object all the details of how it works, and there's also no reason to. The user of the object should only see and access what they need to. Now, we deal with abstraction everywhere in programming. There's 100 things that I can think of right now that we've already done in this course that have used abstraction. For example, when we create an event listener or we use the fetch method, we don't actually know how it works or what's going on behind the scenes. We don't know all the private properties and private methods. We just know how to use it. Even the public APIs that we've looked at, a lot of that is abstraction. We just hit an endpoint. We have no clue what goes on the server. We just know that we hit the endpoint and it gives us a specific response back. Okay. When we call an add event listener method, we don't know how that event listener works. I mean, you might if you really look into it, but the point is you don't need to know in order to use it. So it reduces the complexity of our code. It also reduces the impact of change. So if we have, let's say, a user class and we want to add a new property to it or a new method, we don't have to change the code everywhere where we instantiated a new user. We just have to add the property to the class and it will automatically be available to all user objects. All right, so that's abstraction. The next one is encapsulation. And encapsulation is the process of wrapping or bundling up data and methods into a single unit such as a class. And this concept is also often used to hide the properties or the state of an object from the outside. This is called either data hiding or information hiding. And you actually already have some experience with this. We've talked a lot about functions and scope. So you know that when you create a variable inside of a function, that variable is encapsulated in the function. You also can't access that variable from the global scope or any higher level scope. So you really already have experience with both encapsulation and information hiding. Now, this example here is a class of circle. And again, I don't really care about you knowing the syntax. I just want you to know the concept of encapsulation. So we have a class of circle. There's one property of radius, and we're using the new private property syntax which is the number sign. So this radius is encapsulated, and we can't access it from outside. So when we create a circle object from this blueprint, we can't say circle dot number sign radius. That's not going to be allowed. All right. Now, down here in this what we call a getter, to get the area of the circle, we are using the radius property because we're within the class, right? So we can use it within the class. You can't just use it. You can't use it outside. And a getter is something that you create so that you can get something from outside of the class, right? So if we have an object, we can then use dot area to get the area of the circle, which uses the radius property. All right, so I know that might be a little confusing, but as we go through the next batch of videos, it'll become more clear. All right, so the next principle is inheritance, which is the process of inheriting the properties and methods from a parent class. Now, this is a way to reuse code and reduce redundancy. So we can create a parent class with some properties and methods, and then create a child class that will inherit those properties and methods as well as have their own. Now, to give you a very simple example, we have a class of user, and that has a property of name and just a say hello method. So we can create a child class called admin that will inherit the user name and methods, or I should say user properties and methods. And we do that with the extends keyword in JavaScript. But again, I'm not really focusing on the syntax here. So in addition to the name property and the say hello method, admin also has a delete user method. Okay, delete user will not be accessible to just a user, only an admin. Okay, so that's a very simple example of inheritance. Next, we have polymorphism, and I know that that's a scary word, but it's not that intimidating when you break it down. So the word poly means many, and the word morph means form, right? So it describes situations in which something occurs in several different forms. And this is a way to reuse code. It also allows us to do away with long if-else statements or switch statements and use a single method that will work for different types of objects or work in different ways. So a very common example of polymorphism is when we use the same method or same method name for different types of objects. So for instance, here we have, again, a user object with a say hello method, and then we have an admin class that extends the user class and also has a say hello method, but does something different. Okay, the difference here is it just says I am an admin, but it could be anything, right? And then you could have 10, 20, 100 other classes that also have a say hello method, but it does something different for each one. Okay, so that say hello method has many forms, polymorph. So that's a very simple example of polymorphism. All right, so that's about the simplest way that I can explain these four principles. As we move through the next batch of videos, the next section, a lot of this will come into perspective.